Chapter 4, Section 5. We are going to learn how to read story problems. What I gave you are the sheets here is going to help you to understand some of the words that go with like addition, subtraction, multiplication, division. Addition, plus, sum, more than, increase by, total, in all. Okay, if you see those words, it means addition. Same thing for subtraction. Minus, difference, less than, decreased by, fewer than, or subtracted by. Multiplication, times, product. And you're going to see product a lot in there. What is the product of something? It means you have to multiply something together. Of each factors twice. Division, divided by, quotient, you will see a lot. In fact, this line right here, sum, difference, product, quotient, you're going to see those the majority of the time in word problems. All right? Rate, ratio, half, a third of. Okay? Or a fifth of, or a sixth of, or a seventh of, sure. All right? Those are division. If I'm going to take a half of something, I cut it and I divide it by 2, right? If I'm going to take a third of something, I'm going to divide it by 3. All right. Let's take a look at this statement here. Twice the number n increased by 4 equals m. What is the function, the rule that represents a sentence? In other words, what is the equation that represents a sentence? Well, we're going to break this down. And if you see they did it right here. Twice a number means what? 2n, right? Twice, 2, right? Twice a number. We're going to multiply that number by 2. So we're going to take n right here, and we're going to multiply it by 2. Increased by 4 means we're going to add 4 to it. I'm going to increase it. So I'm going twice a number. Increased by 4 means 2n plus 4 equals m. If I was going to read you an equation, I might read it as 2n plus 4 equals m, right? Or I could say twice the number increased by 4 equals m. I can say it either way. This is when you get into story problems, it's nothing more than that. They're reading you out the equation you have to use. So that's what we're doing here to come up with this here. All right? Let's take a look at some examples. T is 4 more. What do I want to put in there? T is 4 more. So it'd be T plus 4, right? Then the product of seven S. My T looks really funky. I didn't like that. I know it did. T plus 4 is 4 more than 7S. I can say that T plus 4 right here is more than the product of 7S. T plus 4. T is 4. I'm sorry. I did this wrong. T is means equals. Okay? It would be 4 plus, it's 4 more than the product of 7S. Yep. Now I could write that, I could rewrite that as T equals 7s plus 4. Same thing, I just switched it around, right? No cell phones in this classroom. All right. Let's take a look at this. What's ratio? Divide. The ratio of A to 5 equals B. The ratio of A to 5 equals B. So we're going to divide. What are we going to divide? A and 5. So we're going to go A over 5, right? Yeah. Equals B. Go ahead. Let's take a look at number 8. 8 fewer than P times 3 equals X. 8 fewer than P. So think of this. If I'm going to say there are 10 kids fewer in this class than Ski's class. All right? I'm going to say Ski minus 10. In this case here, 8 fewer than P means P minus 8. P minus 8 times 3. Is it P times 3 or the whole thing? It's going to be 3P minus 8 equals X. So this has to be read. When you see 8 fewer than P, means we're going to subtract 8 from P, but P times 3. Okay? So we're kind of reading this from a different direction. You're going to find that subtraction usually works that way, yes?
Basically, that's you're trying to just write the equation.
You're just writing the equation, yeah. That's all you're doing here. Y is half of X plus 10. Y is half of X plus 10. Y equals 1/2 of X plus 10. Okay, Y is. That's my equals. Start getting a feeling for this. It's going to take some practice to work on it. Oh, we got to get over to the other page. This is getting into more of the word problems. All right. 12 cans of peaches. I'll do number 1. 12 cans of peaches are placed into a box. Write the function rule for the number of boxes needed for C cans. How many boxes are needed for 1,440 cans? Well, let's take a look. We got 12 cans of peaches are placed in a box. So if I look at my box here, all right, I'm not going to draw them all out, but I got 12 cans of peaches in here. Okay. I want to show my cans. There's actually 2 deep in this, right? Okay. And placed into each box, okay? Write a function rule for the number of boxes needed for C cans. What is it?
Okay, it's going to be C equals, well, 1, no, wait, okay. Box B equals C divided by 12.
B equals C divided by 12?
Yeah. No, punch me in the head. Yeah.
I got 1 box equals 1 box equals how many cans? 1 box. 1 box. Oh. Now we're going to take a look and we're going to say how many boxes are needed for 1,440 cans.
1,440 divided by 12. That's the answer already.
What's that?
Are we solving it already?
We're right. Well, we got to do the equation first, right? So 1 box equals 12 cans, right? Is that true?
1,440 divided by 12. Yeah, you would.
So if I did this, is this right? It's not right, is it?
No, because C has to equal 12.
C, 1 can. Well, figure. Let's see. We got 12 cans of peaches in 1 box. And we want to figure out how many if we have 1,440 cans, how many boxes do we have? We're going to divide by 12. So what I'm going to do here is I'm going to take number of boxes equals, oh, not 12, C divided by 12.
That's what I said.
And that'll figure out number of cans or number of boxes. If I take 14.
No, he didn't. No, he didn't came up with that. He didn't. Trevor was wrong. Yeah.
I did. Originally I did because 1 box equals 12 cans, right? And that didn't make sense to me when then you turn around because you really do have to divide it by that. Did you?
Yeah, I want to go get a drink of water. He makes me do like 50.
Who's that? Who makes you do push-ups? He does? Okay, for being right the first time, give me 12 push-ups. All right. Yeah, you got to do 12, 13, 14. So do these 3. And I got to sit and think to myself. All right. Do the ones I haven't done. So 5 through 10, and then skip 11 and do 12, 13, 14. You look so good. All right.